Hello everyone, myself Mrs. Archana Mhatre, lecturer in Electronics and Telecommunication Department. In this video, we are going to continue with the first unit of Basic Electronics, that is Semiconductor Diode. So here we will see about PN junction diode. A PN junction diode is a two-terminal or two-electrode semiconductor device which allows the electric current in only one direction while blocks the electric current in opposite or reverse direction. The PN junction diode is made from the semiconductor materials such as silicon, germanium and gallium arsenide. It has a two-terminal called A anode and K cathode. Arrowhead of the diode indicates the conventional direction of electric current when the diode is forward biased from positive terminal to the negative terminal. Now this is the symbol of a PN junction diode. This is the positive terminal anode and this is the negative terminal cathode. Now biasing of a PN junction diode. When the PN junction is formed, the depletion region gets created and the movement of electron and holes stop. Thus the current flowing through an unbiased PN junction is zero. To make the current to flow, we have to bias the PN junction diode. The process of applying the external voltage to a PN junction semiconductor diode is called as biasing. External voltage to the PN junction diode is applied in any of the two methods. First is either forward bias and second is reverse bias. Now first we will see the forward biased PN junction diode. So here the diagram for forward biasing. This is a PN junction diode. When the positive terminal, that is anode terminal of diode, is connected to the positive end of the battery and negative cathode is connected to the negative end of the battery, so that combination is called as a forward biasing of diode. The PN junction diode is forward biased when positive terminal of the power supply is connected to the P side and the negative terminal of the power supply is connected to the N side. Generally, a resistance is connected in series with the diode to limit the current flowing through it. The current IF is a conventional current that flows in the circuit due to the forward biasing. Now this is the operation of forward biased diode. Here you can see the P type is connected to the positive end of the battery and N type is connected to the negative end of the battery. Due to the negative terminal of external source connected to the N region, free electrons from N side are pushed towards P side. Similarly, the positive end of the supply will push holes from P side towards the N side. With increase in the external supply voltage, more and more number of holes P side and electrons N side start traveling towards the junction. The holes will start converting the negative ions into neutral atoms and the electrons will convert the positive ions into the neutral atoms. As a result of this, the width of depletion region and the barrier potential reduces. As a result of this, more majority carriers diffuse across the junction and depletion region will collapse. Therefore, it causes a large current to flow through the PN junction. This is called as a forward current. The PN junction does not permit the current to flow until the external bias voltage overcomes the barrier potential PB. The external bias voltage should be greater than the barrier potential for the current to flow. Now next, voltage drop across the forward bias diode, that is VF. As soon as the applied external voltage overcomes the barrier potential, the current starts flowing. There is a potential drop across the conducting forward bias diode. which has opposite polarities to the barrier potential but has a magnitude which is approximately equal to the barrier potential. The forward voltage drop is denoted by Vf is equal to the 0.7 volt for silicon diode and 0.3 volt for germanium diode. The forward voltage drop Vf is due to two factors, namely the drop due to barrier potential and drop due to internal resistance Rf. Now next, reverse biased PN junction diode. In reverse biased PN junction diode, the positive terminal of the battery is connected to the N-type semiconductor material and the negative terminal of the battery is connected to the P-type semiconductor material. The reverse current is denoted by Is and it flows from the cathode to anode of the diode. Thus, reverse current flows exactly in opposite direction to that of the forward current. The resistance R is connected to limit the reverse current. Operation of reverse bias diode. When the diode is reverse biased, holes in the P region are attracted towards the negative terminal of the supply and electrons on the N side are attracted towards the positive terminal of the supply as shown in figure. Widening of depletion region. Due to the movement of electrons and holes away from the junction, width of the depletion region increases. This happens due to the creation of more number of positive and negative immobile ions. Increase in barrier potential. Due to the more number of ions present on opposite side of the junction, the barrier potential or junction potential will increase. The process of widening of depletion region does not continue for a long time because there is no steady flow of holes from right to left, that is from N side to P side. Now, reverse saturation current. The P region consists of a small number of electrons and N region consists of a small number of holes. These are the majority carriers which are generated thermally. These are the minority carriers which are generated thermally. The minority electrons in the P region are attracted by the positive end of the DC supply. Hence, these electrons will cross the junction and constitute the reverse current Is of the diode. The reverse current is also called as reverse saturation current. As this current is due to minority carriers, it is small in amplitude, typically a few microampere for germanium diode and few nanoampere for silicon diode. Now, VI characteristic of PN junction diode. So, in this graph, you can see the forward characteristic and reverse characteristic of a PN junction diode. The behavior of the PN junction diode is indicated by its volt ampere characteristic, that is VI characteristic. The VI characteristic of a PN junction diode is a graph of voltage across the diode versus the current flowing through it. The VI characteristic can be divided into two parts, forward characteristic and reverse characteristic. First, forward characteristic of PN junction diode. The forward characteristic is the graph of anode to cathode forward voltage versus the forward current through the diode. The forward characteristic is divided into two portions, AB and BC as shown in figure. In the region A to B, the forward voltage is small and less than the cut-in voltage. Therefore, the forward current flowing through the diode is small. With further increase in the forward voltage, it reaches the level of the cut-in voltage and width of depletion region goes on decreasing. In the region B to C, as the forward voltage equals the cut-in voltage, current through the diode increases suddenly. The large forward current in the region B2C of the forward characteristic is limiting by connecting a resistor R in series with the diode. The forward current is of the order of few milliampere. Now cut-in voltage, also called as knee voltage, the voltage at which the forward diode current starts increasing rapidly is known as cut-in voltage or knee voltage of the diode. The cut-in voltage value of the diode for silicon is 0.7 volt and for germanium it is 0.3 volt. Now reverse characteristic of PN junction diode. The reverse characteristic is a graph of reverse voltage VR versus the reverse current IS. Current flowing through the diode in the reverse bias state is the reverse saturation current which flows due to carriers. Therefore, it is treated as a negative current. Hence, reverse characteristic appears in the third quadrant. As the reverse voltage is increased, the reverse saturation current remains constant and equal to I0 if temperature is constant. The reverse saturation current does not depend on reverse voltage, but it depends only on temperature. As the reverse voltage reaches the breakdown voltage value, the large current flows through the diode. Thus, the reverse breakdown voltage of a PN junction diode as the reverse voltage at which breakdown takes place and a large reverse current start flowing through the diode. Now, application of PN junction diode, it is used as a rectifier in the DC supply, in clipping and clamping circuit. It is used for wave shaping. In computers, it is used as a switch in logic circuit. The PN junction diode used as single diode in communication circuit. In demodulation circuit, the PN junction diode used as a detector, voltage multiplier, feedback diode, log and anti-log amplifier using op-amp, precision amplifier using op-amp. Thank you.